Hello guys, my name is Miguel. Today I want to talk to you about multiplexers. First, let's define what is a multiplexer. A multiplexer, or data selector, abbreviated as MUX, MUX, is a logic device that has a group of data inputs and a group of control inputs, which are also known as control bits. The control inputs are used to select one of the data inputs and connect it to the output terminal. Here in our example, we have a 4-to-1 multiplexer. This statement means that this specific device has 4 data inputs and 1 output. To achieve this behavior, the multiplexer must have a number n of control bits and the number 2 to the power n data inputs. In other words, for a formal definition, a multiplexer is always 2 to the power n to 1, which means that this multiplexer has 2 to the power n data inputs and 1 output. Okay, since we already stated the definition, let's put this thing to work. To be more clear about the behavior, let's create a truth table for it. And to be more dynamic, I will be testing the values while I use them to fill the table. Oh, and one important thing to mention is that this following representation is just a representation. We are going to see what we have inside of a multiplexer in just a moment. Okay, on this scheme, I will try to simulate the control bits as switches, which are going to connect the output X to just one input, respectively to its specific combination. Okay, for A equal to 0 and B equal to 0, we have our output X connected to I1. For A equal to 0 and B equal to 1, we have our output X connected to I2. And for A equal to 1 and B equal to 0, we have our output X connected to I3. And the last, which is for A equal to 1 and B equal to 1, we have our output X connected to I4. Okay, now that we have the truth table for the multiplexer, let's see what exists inside of it. To build the MUX 4-to-1 used by us, we will need 4 AND gates and 1 OR gate. Starting with the AND gates, we are going to put some bubbles before them, which represents inverters. The bubbles are going to be placed in a way that only one specific combination of the control bits will make only one gate output the respective input data, while the other gates are going to output a logic 0. Alright, this is the final circuit that represents our multiplexer. And to understand better, let's test our truth table. Okay, for A equal to 0 and B equal to 0, you will notice that when we take these logic zeros into the, let's say, first AND gate, the bubbles will prime the values and input 2 logic 1s. With this, since 1 ended with 1 is 1, this specific gate will output the value from the input data I1. So, when this combination is inserted into the other gates, because of the disposal of the inverters, only the first gate will have a logic value different than 0, and this one is going to be taken into the OR gate, and finally, after this, assign it as the output X. And if you keep trying and testing the other combinations, you're going to realize that the same way to think will be applied and this truth table will be matched. So for this video, that's it. I hope you guys enjoyed, and I'll see you in the next one. Bye bye.